Hello ladies and gentlemen, today for our lesson what we're going to talk about today is something known as the parameters of a linear equation. Basically what this is talking about is what is the effect of the slope and the y-intercept on a line. Now what we're starting off with here, what I want you guys to draw on your paper, you have a nice big coordinate plane there. The first thing I want you to start with is I want you to start with your parent function for a linear equation, y equals x. So as you go to graph that, your y-intercept, there it's 0, 0, and then your slope. Slope is 1. So I want you to go up 1 to the right one, up 1 to the right one. Do that, draw that on there. If you need to pause so you can get it drawn, do so. Now, what we're going to do today is we're going to talk about how to compare slopes of a line. Now, we've got this parent function, y equals x. The slope is 1. And you can see that the slope, the steepness of the line, up 1 unit to the right 1 unit, up 1 to the right 1, all over. Okay? But I want you to think about this. What would you have to do to the slope to raise it? To, in other words, make it steeper. So what would the effect of that slope of 1, what would you do? Well, you increase it. So let's just say, for example, we increase it to say 2. Y equals 2x. What is the effect of the slope? Well, still y-intercept at 0, but now you're going to go up 2 units to the right one, up 2 to the right one. So as you can see, we have an effect on the slope. Y equals 2x is steeper than y is equal to x because it goes up 2 units instead of 1. 2 units up, 1 to the right, 2 units up. So it's always going to be steeper. It's going to increase faster. That's because we increased the slope. Well, we go on the other side of that to decrease the slope, right? To make it a flatter line. Well, so if we go back to our linear function, the parent function, the slope of that parent function is 1. Well, to decrease it, you need a number less than 1. Well, a number less than 1 is something like y is equal to 1/2. All right, a fraction at this point. So as we look at this, to be able to draw this one on there, the slope is up 1 to the right 2, up 1 to the right 2. So we have more of a horizontal change than a vertical change. Right? So as we look at this, the big key to understand is what is the effect on the slope when we change that number. The higher the number, the steeper the line. Now you're going to listen to this, and this is very important. The closer this number gets to 0, the flatter the line. The flattest line you can have is a slope of 0. That's a horizontal line. Go straight across, just like that. That's a horizontal line. That's as flat as you can go. But I want to make sure you understand what I just said. The closer the number gets to 0. Because we're going to talk about next negative slopes. All 3 of these are positive slopes, and they're both increasing. Right? All of them are. This one just doesn't increase as much as the other 2. Right? This one increases the most because it is the largest number. Right? But let's go along and let's try y equals negative x. Right? When we look at y equals negative x, down 1 to the right one, down 1 to the right. The y-intercept is still the same. It's still that 0, 0. Right? But now you notice that it's going off in the other direction. This one's decreasing. Now compare it to the parent function, the one in blue, y equals x. Think about the steepness of the line. This one goes up 1 to the right one. This one just goes down 1 to the right one. The steepness of those 2 lines is actually the exact same. They're both 1 unit. The only difference is this one decreases while this one increases. So the effect of the sign on the slope is the direction that the line will go. A positive slope will increase. A negative slope will decrease. So that's very important to remember, because that's going to affect how you write these lines. And it's very important to know if your line is increasing or decreasing. It's just like if you were in a business. You would like to know, are you making money or are you losing money? So that negative sign makes a big difference. Now when we talk about increasing the slope of a negative line, that's increasing this number. So let's say y is equal to negative 2x. Now, the key here is understanding that just the 2. The number 2 is greater than just the number 1. All the sign will tell us is which direction the line goes. So if you were to graph this one, start at the y-intercept is 0. This one now goes down 2 to the right one, down 2 to the right one. So now, as you can tell, this one is also steeper than y is equal to negative x because of the 2. The negative sign tells us that it's going to decrease. If you compare that to y is equal to 2x, these have the same steepness. Right? They're both definitely steeper than the parent function. It's just this one goes in a different direction. And if we talk about a flatter line, let's talk about y is equal to negative 1/2 x. Well, just like the 1/2, except for now we're going to go down 1 to the right 2. Down 1 to the right 2. So that's very important to remember. And again, if you need to pause this so you can draw these on there, draw all 6 lines on that paper. All 6 need to be on there. Again, the big idea, the larger the number, the steeper the line. The closer that number, the slope, gets to 0, the flatter the line. So, here we go. This is very important. This needs to be on your paper. So, the larger the number, the steeper the line. The closer the number gets to 0, the flatter the line. And again, what does the sign determine? Write this down. The sign determines the direction the line will go. Is your line increasing or is it decreasing? Alright. So, from there, again, write this down. Pause it if you have to. We have 3 examples here. With these 3 examples, we want to be able to put these in order. From the steepest, from what we call the flattest to the steepest line. Alright? So flattest to the steepest line. Sorry for that. So let's try this out. When you look at this and you want to put these in order, the flattest line is one with the slope that is closest to 0. Well, that happens to be y equals 1/2 x. The negative 4 is not, because at this point, when you're doing this, we don't look at the sign. We just look at the 4. So the next one in order, that's just greater than, is going to be y equals 2x. And the steepest of these lines is y equals negative 4x. When you look at this, don't worry about the sign. All the sign tells you is the direction. The steepness of the line is determined by the number itself. Okay? Flattest, a little steeper, and the most steep of our lines. So let's take a look at the next one. Y equals negative x, y equals 4x, and y is equal to 8. This one's here to trick you. So I want you to think about it for a second. If you want to pause it and try to write it down yourself, you can. So as we look at this, the flattest line that we have is actually y is equal to 8. Now I want you to think about that. What's missing? Your x value. The only reason your x value is missing is because you're missing because the slope is 0. The only way to get that slope to get rid of that x is if the slope is 0. 0 times x is 0. So that is the flattest line you can have. So that has to be your first one. That's the least steep of these lines. The next one is y equals negative x. The slope of that line is just the 1, the negative one. And the steepest is y is equal to 4x. Alright, so again, understanding. Flattest to steepest line. Smaller the number, smaller it is to, closer that number gets to 0, the flatter the line. The larger the number, the steeper the line. That's talking about slope. Alright. Next thing we're going to talk about is we're going to talk about the effects of the line and the y-intercept. As we look at this, we have a line here. Right? Well, let's figure out the slope and y-intercept. First thing is slope, real easy. The y-intercept. 1, 2, 3, 4, 5. So here's your y-intercept. 0, 5. Now we need to find the slope of that line. Remember how we write the slope. Change in y over change in x. We need 2 points. Here's another point right here. You can pick, there's other points, there's one down here, there's one down here. You can pick them all over, but you just need 2 points. Again, start at the point farthest to the left. Change in y, 1, 2, 3, 4. We went down 4 units, so that's a -4. The change in x, 2 units to the right. So that's -4 over 2, which gives you -2. So the equation of this line is y is equal to -2x plus 5. So that's the equation of that line. Well, now, question over here. It says shift the line down 8 units. Anytime you see the word shift or you see the words translate, what that is going to affect is the y-intercept. Basically, it wants to take this line and move it down 8 units. So, I want you to think about that. Well, if you want to move this down 8 units, all we have to do, and we'll just use a starting point, we'll just use your starting point, your y-intercept. Count down, 1, 2, 3, 4, 5, 6, 7, 8. So now, you have a new starting point. Your slope is -2, that means -2 over 1, so that's down 2 to the right, down 2 to the right. Right? So now, we have a line that looks like this. We have now shifted that line down. Well, this line now, as you look at it, we have a y-intercept of -3 with the same slope of -2. So the new line is y is equal to -2x minus 3. You can do that just using the graph. But there's another way of looking at this. The original line is y is equal to -2x plus 5. The only thing that shifting or translating affects is the y-intercept. That's it. So, if we're going to shift this line down, we can just go straight to our y-intercept. And if we're shifting down, that is a subtraction. So you can take 8 away from the y-intercept. And when you do that, you end up with our line. Y equals -2x minus 3. All right. So again, shifting or translating the line does not affect the steepness of the line, it affects where it is on the graph. And that is determined by your y-intercept. Alright, so let's try another one. Let's graph this one. So, let's find, again, y-intercept, easiest thing to find. At 0, -2. We need another point. Here's one right there. Once you have 2 points, you can find the slope of that line. And again, every single time, change in y over change in x. So from this point, starting at the point farthest to the left, I go up 1 for the change in y, and to the right 3. So the slope of this line is 1/3. So the equation of this line is y is equal to 1/3 x minus 2. Now, as you look at this, the question what it wants you to do is it wants you to shift this line up 3 units. So again, we're talking about shifting. So if we shift it, all it does is just affect the y-intercept. So essentially what you're going to do is you're going to start here, you're going to move up 1, 2, 3 units. Still the same slope of 1/3, so that's up 1 to the right 3, up 1 to the right 3. Or the other way, down 1 to the left 3. And then you have, whoops, the same line. Shifted up now 3 units. Now, you can find that on here, or as we talked about before, it only affects the y-intercept. So if it shifts up, what we're going to do is actually add to the y-intercept. So we're going to add 3 units to the y-intercept. Well, -2 plus 3 is a +1. So your y-intercept at 0, 1, up 1 to the right 3. There's your new line. Y equals 1/3 x plus 1. Alright. Alright, so our last one. As we look at this one, we have a line that we need to shift down 5 units. So we have to figure out what the slope is of this line is. So we'll find the slope and the y-intercept. First thing, y-intercept, real simple. 1, 2, 3, 4, 5, 6, 7. So the y-intercept is at 0, 7. we then have to find, changing y over changing x, find that slope, do that every single time. There's another point right there you can use. There's a couple more on there. Just pick 2 points. Start at the point farthest to the left. I go down 2 units, so that's a -2. To the right 2, that's -2 over 2, which is -1. So at this point, y is equal to -1x plus 7. So that's the equation of that line. What they ask you to do is to shift this line down 5 units. Well, not a big deal. At this point, to make it easier, when shifting down, you subtract. So just take 5 away from the y-intercept. So y is equal to -x plus 2. You can even check it. Starting here, 1, 2, 3, 4, 5. There's your new y-intercept, 0, 2. Slope, down 1 to the right, down 1 to the right. Whoops. Oh, there you go. So, that's your new line. All right, and you can check it out. Just what we want to see. All right, so that right there was dealing with the y-intercept and how the y-intercept changes the look and feel of a line. So next we're going to kind of combine these things. And this is the types of problems you're going to see on your test. You're going to be given a set of data. And they're going to draw a line on there. And if you notice, that blue line does not represent that data very well. So what you're going to need to do is you need to draw a line of best fit of your own. And from that line of best fit, I want you to decide what you need to do to the slope and or the y-intercept to change this blue line to that red line. For example, start with the slope, the steepness of the line. The blue line is very steep. Our new red line isn't as steep. So what you need to do is you need to change the slope by making it flatter. And to make it flatter, you decrease the slope. You decrease the slope. All right. Next, the y-intercept. Well, if you notice the y-intercept, both of our lines cross at the same spot. All right? So from here, the y-intercepts need to stay the same. All right? Let's take a look at this one over here. As you can tell, that line does not represent those points very well. I would say that this one represents it a heck of a lot better. Now, as we go through this, the first thing is look at the slope. Well, if you look at this, I think these both go in the same direction at the same steepness. So I would say I would keep that the same. The slope is the same. What needs to change though, let's take a look at your y-intercept. This y-intercept up here, we need to move that y-intercept down. Well, the only way to move it down is to decrease it. So you need to decrease the y-intercept. Alright? So, let's try another one. Over here, this line does not represent those points very well. So, we're going to draw a line of best fit. That line is a much better representation of that line. First thing is the slope. The blue line is a lot less steep than my new line. So I need to make the line steeper. The only way to make it steeper is to increase the slope. So I'm going to increase the slope. Now the next thing is your y-intercept. This y-intercept is way down here. We need to move it up there. So to move a y-intercept up, you need to increase it. So you need to increase the y-intercept. Alright. Last one. This line does not represent these points. I believe that is a much better representation of those points. Now, this one's a little tougher. When you look at the slope, the actual steepness of both of these lines is actually very similar. They both but the problem is the original line, the blue line, decreases, your new line increases. So the slope itself, the steepness is the same. The issue is in the sign. You need to change the sign to a positive. We have a negative slope with the blue line. You need a positive slope with the red line. Now the y-intercept, that also needs to change. Here's the blue one. You want to move it all the way down there. Well, to do that, To move it down, you need to decrease the y-intercept. You need to move it down, so you decrease it. All right? All right. So, we're not going to do the last two problems on there. So you see the two tables. Don't worry about those two tables right now. We'll talk about that kind of stuff a little later. So, this time, we're done. We'll have an assignment in class. I want you guys to have a good evening. See you later. Bye.